Good morning, everybody, and welcome to another UKAA webinar. It is a fantastic series of webinars on a wide range of topics throughout the year. If this is your first one, welcome. If you've come back again, you know the score, you know the format. Please ask as many questions as possible. Today's webinar is entitled The Future of Heat, Hydrogen or Electric, the electrification of heat. So I'm personally very interested in hearing all about this because, as you know, my side of things is in the utilities piece. So I'm really looking forward to our expert panel telling us how they're going to save the world. With that introduction, over to you, David.
Thanks, Tim. Perhaps we should start by introducing ourselves. I'm David Miles. I work for Automate, which is a company that produces building monitoring and control systems for, among others, the build-to-rent sector. Courtney?
Sure, I'm Courtney DePaula. I'm from National Grid. I'm in our future markets team, looking at how we decarbonise heat.
Prashant?
Hi, I'm Prashant Vazay. I'm acting head of climate change at London Councils, which is the representative body for London boroughs. And I used to be a civil servant working on climate change and energy before.
And Josh?
Good morning, everyone. I'm Josh Shimmin. I'm a chartered building services engineer with over 10 years experience working, developing energy strategies and including large-scale residential. I now head up our consultancy team at Automate.
Thanks, Josh. So to contextualise the discussion, our fundamental problem is that in Britain, in the domestic sector, we use too much gas. I mean, the last English housing survey said 86% of homes use it for heating, space or water heating, in most cases both, and about a third of our electricity is generated by burning gas. There's two obvious issues with burning gas. I mean, first of all, greenhouse gas emissions. You can't burn gas without producing carbon, and the UK is committed to not doing that by 2050. And secondly is the problem that gas is traded on the international markets, which puts us at the mercy of fluctuations in those markets. And as we've seen very much over the last couple of years, China has a spat with Australia and bills in Basingstoke go up, and that's not going to change for as long as we're committed to using gas. Now, the current net zero pathway includes a decision to phase gas out, and the two options to replace it are hydrogen and electric in the domestic sector. And the net zero pathway schedules a decision in 2026 about whether the UK is going to go down the high hydrogen or the high electricity route. I mean, 2026, not very far away, could be as few as 4 or 5 prime ministers away, the way things are looking at the moment. So what we're going to talk about today is, we'll start off by contextualizing what exactly it would mean to have a high hydrogen or a high electricity route, both of which have a whole set of issues and opportunities. And then we will take questions from the floor. So please type in your questions and Tim will wrangle them. But let's lead off by saying, what does the high hydrogen route actually mean if you're interested in either new builds or renovations? And perhaps I'll back that question to Courtney as the hydrogen expert on the panel.
Sure. So the high hydrogen route would mean sort of repurposing our transmission and distribution network to run hydrogen. We're looking at the possibility of blending even from next year. So they're going to start looking at how we can blend 5 to 20% hydrogen into the existing gas network. And it would mean sort of trying to maintain what the consumer is used to. So you'd still have a boiler in your house. There's a lot of research going on what type of boiler that would need to be. Could we just retrofit existing boilers, or is it a new technology? So a high hydrogen route would mean very much similar to what we have today, just changing the gas that comes into your home.
Prashant, did you want to come in on that or follow up with any questions there?
Well, I think it is just worth mentioning that the high hydrogen route does require some method of actually making the hydrogen, and so it's not totally divorced from high electricity, because one of the ways of making hydrogen is by electrolysis, and that will require a lot of electricity. The other route is reformulating gas, which requires a lot of gas. So, David, your point initially about weaning ourselves off imported gas might be an issue, at least in the current ways we make hydrogen. with CCS accordingly, just to make sure it's consistent with decarbonisation.
Yeah, there's a lot of challenges around the production and transport of hydrogen. So a high hydrogen solution, a hydrogen economy, would require a lot of challenges to be solved in a quite short amount of time. So while it might be a good solution in terms of not changing the consumer experience too much, there's a lot of really significant challenges. So if we do blue hydrogen, which is hydrogen made from natural gas, you've got the carbon capture and storage issue that needs to be solved. And if we go green hydrogen, which is hydrogen produced through electrolysis, then we would still need quite a lot from our electricity network to do that. So both provide really significant challenges in order to work.
I mean, for somebody with a building, we would be talking about completely retrofitting appliances, wouldn't we? If we have to go down, if we go to 100% hydrogen.
Yeah. So the appliances would definitely need to be, updated to burn, because hydrogen burns at a much higher temperature than natural gas does. And there are other issues, particularly around non-greenhouse gas emissions from burning hydrogen, that aren't entirely clear. So you might get more NOx and SOx emissions from burning hydrogen than you would get from what we see from burning natural gas, which could have a negative effect on air quality, especially in densely populated areas.
Josh, did you want to come in on hydrogen there?
I guess the only sort of other points to add from my side is that the great thing about hydrogen is it's a kind of one-stop shop, for heating and hot water. It's a really good replacement for boilers. The kind of problem with it is that we need kind of mass development of networks before we can deploy that technology on a wide scale basis. So in terms of that 2026 deadline, we're waiting for the decision to be made before we can kind of launch down that pathway, whereas a high electric pathway is open to us now. So I just wanted to kind of make that difference there. I mean, both of them I still need to be grounded in the need to reduce demand more generally, and that's a buildings question, which we can talk more about in the session, I'm sure.
Well, that segues quite nicely onto what the high electricity route means. And I mean, Josh, would you like to expand on that? Perhaps?
Yeah, of course. So the kind of benefit of high electric and also the downside of high electric is there are a lot more solutions available in terms of how we might heat or provide hot water to our buildings. Obviously, our buildings need electricity for a lot of other services like lighting and having this webinar, for example, requires electricity. But really what we're talking about here is about heating and hot water as the two big main players in the UK for energy demand when it comes to domestic. And there's a range of electric solutions available to provide those services. Some of them provide both heating and hot water, some of them provide just heating or just hot water. So the options are maybe less clear, I think, but as I said before, more available now. You could have simple electric panel radiators, for example, to provide heating, but that's not going to provide your hot water, so you might need another solution for that. The problem, one of the problems with electric, and we're especially seeing it at the moment, is obviously from a cost point of view to the customers and the people using the electricity, is that typically we're sort of 2 or 3 times more expensive than gas, which when we're moving to hydrogen, I think we're still within that kind of double the kind of pence per kilowatt hour sort of region. So build shock is a big question, and that's where things like air source heat pumps or heat pumps in general kind of start to look to close that gap or trying to address that gap in cost, essentially. Now the downside of an air source heat pump is it's sort of or a heat pump in general is it's advertised as a direct replacement for a boiler, which it is not, whereas a hydrogen boiler could be. So there's a difference there, and really what we're talking about in terms of difference is about how we control our buildings and also how we use heat in a building. And things like a heat pump, they're sort of a low and slow. They like to be on for a really long time and they heat buildings up slowly. and sort of run at a continuous rate, and that's where we see the highest efficiencies. Whereas a typical boiler, you might whack it on for an hour in the morning, and a couple of hours or a bit longer in the evening, especially at the moment. And that's how you heat. So there's a difference there in how we use the buildings, how we control our buildings. And then also, to make those technologies possible, we generally need to have less demand. I mean, the great things about gas and hydrogen is you've got a really good store of energy that you can release quickly, whereas with electricity, you don't have that in the same way. So it makes it even more important for us to reduce demand to allow us to deploy those technologies, which kind of goes hand in hand with what we're trying to do, decarbonising in a more general sense. Then my sort of fellow panelists will be better at saying about this, but there's obviously then the issue about grid and where does that electricity come from, especially as we're seeing a push for electrification of vehicles as well. Suddenly we need a lot more electricity on the grid, and my very limited understanding is that's going to push us over the edge. So that's an issue, but then it's also an opportunity for development and to think about smart solutions. So things like having local storage, moving electricity around in your building and generating locally, come to the fore. And that's where we see things like variable tariffs coming in to use that energy more intelligently. So I guess I've just threw out a load of points there, but from a kind of electricity point of view, it's very much a kind of it depends, and it requires a lot of thinking sort of approach. Whereas maybe hydrogen is sort of seen in the house is a very much a direct replacement potentially, but it has obviously this wider issue of network. So that's how I'd summarize that from my side.
I mean, Courtney, I think perhaps you could speak to the grid issue. You've probably done a lot of the thinking that Josh is talking about there.
Yeah, it's definitely something that is on our radar at National Grid, both from transmission level issues and distribution level issues, because we own both. So what we expect to see is a double clustering element. So if you have an EV, you're likely then to maybe want to install a heat pump. And right now, looking at ED2, at the distribution level, the latest price control with Ofgem, there are targets there to really ramp up those connections for consumers, so they have the right connections in their house to allow for this double clustering effect. And for the next few years, I think the distribution company sort of have a good plan, but transmission then need to be doing the right reinforcements on the network so that, we're not sort of caught by this S-curve of technology uptake and suddenly the distribution networks can't cope anymore. I really agree with Josh's point on there's going to be a lot of local solutions. A lot of what I'm hearing in the industry, especially in the last few months, is we're looking at this hydrogen versus electricity. And I think we really need to take a whole systems approach, and a lot of that will be regional solutions. So what works in one area of the UK might not work in another area. So looking at all the different technologies and solutions and seeing what works for specific communities and locations is going to be really important.
So just to follow up on that, I mean, because the net zero pathway does specify the decision between the high hydrogen and the high electricity. I mean, are you saying that presenting that as a dichotomy might be a mistake?
Yes,
Right.
I think we're going to need to use all the tools in the toolbox if we want to reach net zero, honestly. So I think there is a role for hydrogen. The FES sort of shows us, especially around seasonal storage. And I think in some industrial areas, it makes a lot of sense. But I do think we'll also see high electrification. And we need to prepare the network for that, and we need to be ready for that, and also wrap around that the efficiency piece, which I'm really glad to see that messaging from government in the last few weeks to sort of push how do we make our homes more efficient as well and just reduce that usage overall. So we've got to use everything we've got to get ourselves to net zero. And it's all going to happen a lot sooner than we think. So I know 2050 feels like a long way off, but a lot of these technologies and stuff really need to be in place and ramping up in the next 5 to 10 years. So, you know, we do need to look at all of the solutions and be collaborative and really think about what are the best solutions across the piece, and then also for each individual area within the UK.
Can I just come in on that, David? Is that all right?
Yeah,
I mean, I completely agree with Courtney as well. And I mean, I guess just within the sort of residential sector, you know, the real sort of divider that we've got at the moment is between retrofit and new build, really. And especially from an electrification point of view, it's a very different approach for those different types of buildings. So what we see in new build buildings is actually, especially apartment blocks, is that actually the demand for heat, for space heating, is very low. You know, it's quite small, but obviously you need it for longer. You know, especially now and over the winter, we'll need it for longer. Whereas hot water, that is a much higher demand, and it's an all year demand. So there's a kind of a different profile to think about for those two different services there. Whereas for existing buildings, you know, generally heating is the thing that dominates massively, and they're also the buildings that are harder to treat in terms of reducing demand. So that's why it's really important to push this messaging around how do we do that, and how do we learn to do that better, and to roll it out in a more wide scale way.
Can I just come in on a couple of those
please? Yes.
Yeah, I mean, I very much agree with things that both Courtney and Josh have said. It isn't a bifurcation between one or the other. And what you need to look at is the kind of the properties of hydrogen and the kind of, I think what other people have already identified is hydrogen is very good at high temperature, localized energy demand. And I suspect that going forward, some of the industrial uses where you can actually identify particular clusters, you know, near to ports and stuff. That's where hydrogen will get utilized. And if you look at the strategy, my reading of it was that they're talking about tens of kilometers of hydrogen pipeline, not hundreds of thousands, which is what you would need for introducing hydrogen throughout the kind of network. So I think it's worth just identifying that hydrogen has certainly got a use, but it's more for the high temperature processes. And some of the, I know that some of the early kind of work that's been done in the southeast has been looking at, you know, British sugar and some of the kind of industrial processes like that. The other thing that's a really major driver in local authorities' minds and politicians nationally is price. And if you think about where renewables price is at the moment, you know, wind is coming, offshore wind is coming in at something like £50 a megawatt hour, which is 5 pence a kilowatt hour. Solar's pretty comparable. And currently there's tens of gigawatts of offshore wind that's been permitted. So government is currently anticipating a massive expansion in renewable energy, and that is for the reasons we've been talking about, you know, electrification of heating and also the EV charging network. So that is the kind of the way I think we're anticipating a lot of changes. And the last thing to mention is with heat pumps, there is actually quite a possibility of actually having lower energy costs. I mean, typically 1 kilowatt hour of electricity is converted into 3, maybe 4 usable units of energy because of the low temperature nature of heat demand. So there is a possibility that bills will come down. I don't see that being possible with hydrogen very easily. Hydrogen is quite a wasteful, green hydrogen is quite a wasteful way of using electricity compared to a heat pump. So I think the push at the moment on new build is almost certainly going to be for heat pumps. On retrofits, it's a mixture of this energy efficiency to moderate the overall demand of the building. And then the jury is still out whether heat pumps are going to work there, or as I'm sure, David, you want to go into next networks. So I'll stop there.
Can I just add a point to that, if that's okay? I mean, just to, I just want for us to be clear that, you know, there are other solutions to heat pumps in new builds, and they, used in the right place, they are a good solution, but they're not always the best solution. So that's something to watch out for. Heat pumps are great at operating at low temperatures, but they're not very good at providing hot water. And hot water is what we're seeing as a growing demand in new build, especially in apartments. So we just But that said, we can use heat pumps in slightly different ways. We find it combining heat pumps with ventilations as well. So we're using the exhaust air from buildings that is warm to then provide hot water is a really good way of using a heat pump, for example. So it's using that heat pump in the right way, to using it at the right time. So it's a balance. There's definitely a balance to be struck there for sure.
If I can just come back on something that Courtney and Prashant raised about possible applications of hydrogen. I mean, the way you're describing it sounds like it's probably got a lot of applications, but the problems are exactly the issues that come up with the domestic sector, where you have to have large numbers of disseminated pipelines. And I mean, given that capacity for producing hydrogen isn't that great, it does make me wonder if the domestic sector might not be the first call for it.
I would agree with that point in general. Hydrogen is quite an interesting molecule, and it is really important for high temp industrial usage. Currently, the hydrogen production industry accounts for something like 2% of all greenhouse gas emissions. So hydrogen is actually an issue that needs to be decarbonized in the first instance before we can see it as something that can actually enable a decarbonization. And then it still goes back to, well, how do you decarbonize hydrogen? You need green hydrogen, you need electrolyzers. We need to, get economies of scale on electrolyzers, because right now they're quite expensive and you don't have like mass production of them. So there are significant challenges with, big use of hydrogen, and we're going to want to use it in the areas that they really provide value for how we live, particularly around fertilizer, which enables a lot of the food production in the world. So we're going to need to use it there first before we can potentially use it for other things.
I mean, just to carry on some of those points, I mean, we do run the risk of replacing, OPEC controlling prices of energy with a solar alliance doing a similar thing. I mean, UK is not the best place to have a lot of green hydrogen production, I don't think. I mean, really, the countries that are likely to dominate are between the tropics. And where we're seeing cheap hydrogen production is really in the Middle East countries. India's actually producing an awful lot. So it's interesting. What we might be doing is substituting one import demand for another with a green hydrogen approach. So I do think that strategic kind of issues might sort of come to mind with decision makers, and perhaps moderating the usage of green hydrogen for high temperature processes, for sure. For some of the lower temperature processes, I'm not so sure.
I mean, Courtney, you mentioned interseasonal energy transfer, which I mean would seem like, because obviously presumably you're thinking store up loads of hydrogen in the summer and then burn it in the winter. But I mean, actually, from somebody who's building a flat, that's effectively high electricity route, isn't it? Because I mean, that's how the energy would be distributed to the building if we go down that route.
Correct. Yeah. So basically, how the Feds see it is, we produce excess electricity in the summer from our offshore wind, and what's the best way to store that excess energy so we don't just have to do curtailment, really avoid curtailment costs, which are a separate cost to the consumer, right? When we have to pay people to turn off things because we don't have the demand. So I think there is a role there. How that electricity is then, hydrogen is then stored and then used, there are a lot of options there, right? So we could use them for heating if we have the right network in place. But if we don't have that, we could use it for fuel cells, which would then allow for filling in gaps on electricity generation in the winter or higher demand periods. But again, then you've got the cost and supply and capex around fuel cells. So again, I don't think there's no silver bullet solution here to how we get to net zero. There's a lot of options, a lot of creative solutions that will need to come online to get us there.
Perhaps we could take a few questions from the floor. Tim, I know you've been watching that box.
I have been indeed. Yeah, we've got three questions that have come in. Well, two questions and a point. We've got a question to Courtney about the hybrid model. and wondering when that is being launched, or where it's being launched. So where is that hydrogen going to be mixed in with the gas? Is that just across the grid, or is there a specific area?
I think there are specific testing that has been occurring over the last couple of years. So so basically the reports I've read is saying that we're ready for some hydrogen blending, but I think that will be in localized areas of the network. And it would be to help bring down some of our greenhouse gas emissions from our gas network, rather than, you would notice it in your home sort of thing. So it'd be 5 to 20, I think up to 20% has been signed off as what would, be okay in current networks without people really noticing much of a difference in their home.
There was some early trials on cost. Sorry.
Yeah, there were some early trials at Keele University. I think they were just using, I think it was just grey hydrogen. So it's basically not at all green hydrogen. High carbon. Yeah. But they did prove that the cookers and the boilers would work satisfactorily at
still work.
Lens, yeah.
And there'd be no impact on costs or anything like that. They would just be fed in as a normal gas on the normal gas tariff.
I'm not sure. Yeah.
But only for the trials.
Yeah. Obviously, on an ongoing basis, there'll be a new pricing structure, but it's not going to affect the current supply, that blend. Okay, we got another question around grid capacity. So this might be one more for Josh, maybe. We experienced issues where grid capacity in one area has been allocated to a data center, and there is insufficient capacity for us to proceed with constructing a new build-to-rent block with air source heat pumps. What is being done at local authority level to plan for grid requirements?
Do you want me to say that one?
I was going to say I might have to push that one over. Yeah, thanks.
Prashant, I think this is very much your area.
Yeah, I mean, I'm certainly in the west of London. That is a big issue. So a number of the boroughs in London have been complaining that data centres along the M4 corridor are gobbling up demand. I think, as Courtney mentioned, there is the kind of the ED2 process of, I think it's SSE is the network operator in that locality. So that's trying to work with National Grid to resolve it, but it's not a very fast process. It's not an easy win, but once the grid, I mean, some of the issues, I think, please correct me if I'm wrong, but it's some of the sort of transforming from the high voltage to the low voltage, some of the new kit that was needed there. I think it's something where Ofgem, the DNOs, the distributed network operators, and the grid will have to work together and just get faster at resolving these stuff. I mean, these electricity distribution price agreements are 7 years long at a time, so we need to make sure that they're even more flexible than they are. There are some built-in flexibilities, but they need to be even more flexible to respond to growing demand quickly.
Yeah.
Courtney, I was going to say, could you start by defining ED2, which is a term that's been used a couple of times?
Yeah. So both distribution and transmission are regulated entities with Ofgem, and so we have what are called price control periods. So ED2 is the second iteration of a RIIO price control period. So RIIO stands for revenue equals innovation plus investment equals outputs. So basically, it sort of creates a market for these regulated entities to perform and deliver for the customer at a competitive cost. So the RIIO period started in about 2013 for transmission, I think 2015 for distribution, and they were initially 8 years long. And it was decided that was way too long of a period to manage the changes. So this latest set of price controls are 5 years long each for both transmission and distribution. Transmission was 2 years behind distribution. So distribution's new price control starts next spring. Transmission started in spring of 2021. We've recently had some conversations with Ofgem saying that the next price control model will not be around the RIIO model, because they realize it's maybe not fit for purpose anymore to drive the speed and pace of investment that's required on the network. So we're in open conversations across the industry, both at transmission and distribution level, of how it's going to look beyond this price control period, which will finish in 2026 and 2028, respectively, for transmission and distribution. We're talking about sort of speeding up that ability to do anticipatory or just-in-time investment to allow for that connection between transmission and distribution to not take a long time, because what we anticipate seeing, as we've seen with EVs in heating, sort of an S-curve uptake, as you see with new technologies or new ways of doing things, and the infrastructure needs to be ready for that.
I mean, do you have any more to say on the issue of the issues that Prashant raised about? Well, I suppose the question was about giving enough electricity to data centers and where things stand with that.
Yeah. So again, that's us looking at how can we improve our connections, and that's something we're always looking at National Grid, to make sure that we can keep up with the pace. But sometimes we've got to go back to the regulator and the policies that are in place that allow us to do that, and feedback that this maybe isn't fit for purpose. So that is something we're actively doing, because we realize it's causing delays already, and it's only a problem that's going to get worse. So we are actively working on that.
So in West London, there's a process called the LAPE, which is the Local Area Energy Planning System. And the purpose of that is to both sort of anticipate what demand is going to be. So it involves local government speaking to all the stakeholders, so with the data users. I mean, I don't think anybody's keen to choke off growth. So in new businesses want to come in, but what we need to do is be able to talk to these people in a sort of structured way, anticipate what's going to be needed. The big employers there are Heathrow, some of the kind of M4 corridor business parks, and then work with SSE, UK Power Networks, and National Grid collectively to make sure that we've got a reasonable view over the next 5 to 7 years of what demand might be. There's massive programs also to install EV charging networks, which is really under the local authorities' gift. They plan those out, but it's also some of the kind of the big employers and the two network operators and National Grid.
While we're on data centers, there's another question coming in from Ahmed about whether there's any heat capture from data centers, and whether that is a strategy that we could use in West London to create heat.
It has been trialled in North London. So in North London around Islington, they're trialling that. I mean, it's not a huge source of energy, let's be honest. We're talking about a few megawatts of energy, but it's being used for some district heating networks for a few buildings nearby.
Yeah, but I suppose that goes back to the point about being local, doesn't it? And creating local solutions. And it might only be a few megawatts off that factory, but then if we collect all the heat off all the factories and distribute it locally, then the impacts can become bigger and bigger and bigger. There's also probably a bit of a social responsibility on ourselves to delete emails, so they're not stored in data centers that we don't need. And that's part of the education process, to understand, well, do you want to be able to cook your food, or do you want to be able to store 15,000 emails on Gmail that you'd never ever read again? And there's no direct relationships between those behavioral change things and actually what the impacts of those behavioral our behaviors around data are. So that's probably another webinar, but that's probably certainly something to explore.
Josh, did you have something to say on that?
Yeah, I mean, I was just going to kind of come in. I sort of leads quite well onto heat networks, that question as well. And I mean, really, it's a question of energy flows and energy demands, really. And it's kind of a lot of what we're discussing here, sort of highlighting that a lot of these issues are outside the boundary of the apartment block or the building that any developer might be making, and which kind of dilutes the issue and makes it more difficult for any developer to know what's the right thing to do. But certainly from an energy center point of view, there's in theory, there's a constant sort of low level bit of energy there that can be used for something. Actually, we find that heating demand is much more peaky than that, but maybe a base load of hot water energy might be useful. It's quite interesting from a heat network model, and I'm not a big fan of heat networks, I have to say, but I think from a waste energy point of view, they start to make more sense. I mean, if we look at heat networks sort of pioneered in Scandinavian countries where their planning models are very different. They have large industry within their cities, so that waste heat can be used locally, whereas in the UK, we tend to push our industry out of our residential areas. So it's very difficult for us to share that energy around. So it's good to hear that there is some developments where that kind of thinking is in development terms, where, you know, we're building a lot of houses every year at the moment. You know, it's not all the problem. We've got a big retrofit problem as well, but we are building a lot of houses as well. So it's good to see or good to hear that, yeah, there are potential developments which are being thought in energy terms. You know, where is energy being used? Where can it be shared? You know, that's, you know, it does unlock potential efficiencies. But I guess the point on heat networks is, you know, if it's waste energy, that's the best way to go. But not so great for direct electricity.
Heat networks are one of these kind of Marmite topics. There are people who don't like them, who sort of talk about the UK examples and evidence of it since the 70s, and people who like them who point to Scandinavia. I should mention that the regulatory framework for heat is changing quite dramatically. So under the recent energy bill, there are powers now for zoning of heat, so that in areas, London's got a number of these, where there's identified high demand for heat in terms of density per square metre. Those can be zoned by local governments as heat network areas. And then suddenly some of the powers that Josh is indicating out of identifying where these heat sources are of waste heat, how much they are. And then I think the powers to forcibly connect people to the network are there as well. So data centers are certainly one, but TfL is another big one. So some of the kind of waste heat from tube stations is really quite substantial in central London. And I suspect the railways elsewhere are probably quite important sources of heat as well. Then, you know, within London, we have about 6 incineration plants for waste. These are each about tens of megawatts each. So there are discrete energy sources which could be linked to heat networks and are being linked to heat networks. Yeah,
I mean, and that kind of goes back to Courtney's point that, you know, it's different solutions for different areas essentially, and heat networks is definitely one of them. I mean, the sort of further points just to highlight on heat networks is one problem with heat networks is it locks the customer into a particular solution. So, you know, with electricity, you can choose where your supplier is, and there is some way to reduce your bills or to negotiate your bills. Whereas with heat networks, you have a particular supplier, and then with that comes a load of other costs that sometimes are hidden. So yeah, it's just another point to make on heat networks there.
Yeah, I mean, that is a fundamental problem, though, isn't it? Because I mean, the whole UK energy market is based around the customer being able to switch suppliers if you don't like the service you're getting. You can't do that if you're locked into a heat network. But I mean, Courtney, you look like you wanted to come in on heat networks there.
It's just been an area I've been looking at recently. I was at a Kenza event a couple of weeks ago where they were talking about their ideas around heat networks and sort of making it like a broadband installation in your neighborhood. And they've got a lot of ideas in terms of storing that waste heat underground so that it actually reduces the load on the electricity network, which I thought was quite a creative solution. So and they've got their little like mailbox things that you can put in your flat or whatever.
Shoebox.
That's it. I keep calling it a mailbox, but yeah, it's just a really, you know, again, creative, interesting solutions that I think do a lot of really good things to the UK in terms of, you know, building up UK industry and businesses. They manufacture here, so you've got that whole element around energy security. They're looking at how to make things efficient. So I think it's really interesting, the heat network concept. When you compare with Scandinavia, you know, one of the key elements there is that their housing stock is a lot better than ours. So in a lot of ways, of course, it's, you know, they've had a lot of success with it. And it goes back to that point, you know, we got to look at the fabric of our buildings and the efficiency piece. And that's something that, whether you're for hydrogen or electricity or whatever, I think we can all get on board with, is that, you know, the housing stock needs to be looked at as well in conjunction with all this, and can maybe be some low-hanging fruit to get us there while we're, you know, sorting out the technological and more complex solutions for the long term.
Could you just briefly explain the shoebox?
So the shoebox, it's like a mini. It's smaller than a boiler in your house, and I think it serves sort of a similar purpose. So it's connected to a heat network, and it brings the heat into your house. I think it works really well in sort of high density population areas, so like flats and you know, terrace houses and that sort of thing. So their idea is it's similar to how you would install broadband in a neighborhood of sort of densely populated houses.
But
So
I mean,
where
this
you
is,
can't have.
sorry, Josh.
Sorry.
It's essentially, Connie's right. It's a distributed ground source heat pump solution. So the multiple people share the same ground loops, but they all have a heat pump within the house that taps into that loop. Essentially, that's how it works.
But this is the system that allows the the water in the heat network to flow at a lower temperature, so you lose less heat energy. Am I right in thinking that?
Yes, it is.
Yes,
I mean,
yeah.
I don't know. It's a different form of heat network to an ambient heat network, but it is a heat network nonetheless. Yeah.
Yeah, there are some interesting sort of hybrid ideas here.
Yeah.
It's one of an interseasonal store one where essentially aquifers are being used, which tends to have a sort of a steady temperature all year round. So in summertime, heat might be pumped down there, excess heat, elevate the temperature a little bit, and then in winter, it's that slightly warmer water is then circulated around, and then Josh says heat pumps, probably shared heat pumps, so one heat pump for several blocks of buildings is used to raise it to a temperature that would be used for a building. Then you might need to then, to the other points about hot water demand, raise it with just a resistance heat to get to a shower temperature. But that's quite a modest way of actually, economical systems way of keeping water at low temperatures where there's less losses, and then just heating up for that little bit of hot water you really need for showers.
I mean, the downside of these kind of heat network solutions is they're very complex. You know, they're incredibly complex, and there is a lot of room for failure, and also how do they get maintained, and where is the cost of that borne out? You know, I've seen examples where the actual maintenance costs, or the kind of the surcharge of, or whatever you call it, of the heat network can be more than the energy that you pay for, and so you know, it's making sure that these options are kind of compared in the round.
Yeah, and I think there's always short-term pain on new technology and new systems coming through. The more engineers that know how to fix heat networks, the lower the cost will become over time. And with regard to the supplier point, it's quite interesting. The supplier market is completely broken. You know, 32 residential suppliers have gone bust on the basis that the model that runs the choice is a marketing model. It's nothing to do with the price of the utilities. It's to get more customers on to grow. So that's been exposed a bit, and I think the beauty of this conversation has been actually it's all got to be on the table. We can't hold on to anything from the past really, because actually we've got a problem moving forward in terms of not only carbon, but in terms of cost. And consumer choice legislation that was based in the 1980s is, maybe not as relevant as it was, but back then. Now we've really got to be able to share stuff, and we've got to work out a decent way to share it, and to make sure that we all pay our fair share. And that brings me on to another question that has come in about nuclear. Who wants to take what role can nuclear power play in getting us to net zero?
That sounds like one for Courtney.
Courtney's got to have all our questions.
I know.
All right. So again, I think nuclear is a great source, because it's low carbon, it's reliable, you get it up and running. We've got a lot of good safety, lessons around nuclear from past failures, so I feel like it's quite safe. The issue we have obviously is cost and lead time. So while I think it's great that that's in the energy strategy as a way to help us have energy security within the UK, it just takes a long time to get online. So I think we definitely should keep it in the plan as a role to play, but we've got to sort of recognize that it's a little late to the party, and we're going to have to allow for the time for those those sources to come online. And in the meantime, we've got other, ready technologies and stuff that we might need to bring into the mix. So I think nuclear is absolutely important and needs to play a role, but we've got to make sure we've put it on the system in the right way.
Mm-hmm. Josh or Prashant, did you have anything to say on that?
Well, just very obvious points. One is 150 pounds a megawatt hour nuclear. One is a 50 pounds a megawatt hour offshore wind. Just heard that onshore wind is going to get planning permissions once again, so that's even cheaper. I mean, how on earth do you integrate nuclear power into this wonderful world of heat networks when you've got things in, hundreds of miles away from populations? I think we keep on talking about nuclear power as if it's a viable option. I don't think it is.
I guess one other point to bring on nuclear is that, I mean, if we're thinking about this from a whole life carbon perspective, nuclear is great from a kind of start, from delivering, carbon up front, but then what do you do about decommissioning, and what do you do about storing of that material? Where is that accounted for, and the, from a carbon and a cost point of view, and a kind of overhead on the country, essentially. So just to bring that point in as well.
Yeah, right. A reducing balancing fuel, I think, in the end. So this is Prashant, this is for you. We are building a new build-to-rent building next to a tube station in partnership with TfL, and we're being required to connect to the gas CHP DHN in Enfield, run by the council. Why are councils not being required to use waste heat sources from DHN as well?
The Enfield one is actually a council-owned company, Meridian, I think it is. So the councils are very much part of the DNH distributed network solution. They're often the owners of the district networks. Their social housing is often connected to it. And most of the district heating linked properties in the UK are actually council-owned. Yeah,
and maybe where it's kind of practical, they'll connect offices as well, won't they? Where they can, yeah.
It's simply one of piping costs. I mean, so some of the regulatory changes that are being proposed in the energy bill will allow more simple powers to dig up roads, all the boring stuff that utilities take for granted. At the moment, district heating networks don't have all these illegal powers yet.
Yeah.
We take another one.
There's a few points around behavioural change. If the grid can't cope now, how will it cope if all developers go to air source heat pumps? The pressure on is for operators. What I'm hearing is developers and operators saying to me, yeah, but we're being told we have to be better citizens, better companies. We have to be better. We have to reduce our carbon impact on the environment. But when we try to do it, it's almost impossible because there's not enough capacity on the grid, or there's red tape put in their way. How is that going to change?
Well, I'd like to believe that the late process will make an improvement. So this process of just getting people in the room, that we're in a period now of profound change, and the distribution companies, transmission companies. I mean, local authorities are to blame as well. Some of the planning permission delays are actually local governments. So there's nobody that can sort of point in the current network system and say we're doing a great job. We need to get better at this.
Josh or Courtney, did you want to comment on that one? I mean, it sounds like a question of there's a lot of different moving parts that all need to move together, and they're not. But
it is a constant challenge for us at National Grid, because we have worked in a certain way for a number of decades, and it's a massive amount of change. And we do have those conversations internally. We are working on engaging with our customers and improving that, and also having those conversations with the regulator and government about how can we improve the frameworks and really get us to a good place to be fit for purpose as we go into the future of what the network needs in the next 2 to 3 decades. Because I think the way that we've done sort of linear investment in the last 3 decades isn't going to work for what we need to do for the next 3 decades. So yeah, I think there is a recognition that that it's not fit for purpose. And I think there's a lot of really good noises happening across the industry about how do we make it fit for purpose. And I think it's important to have sort of conversations and listening sessions and across all the different stakeholders in this about how do we come to the right solutions.
I mean, Josh, you've probably felt the pain behind that question a few times yourself, I imagine.
Yes, yes, I have. I mean, I guess it comes. I mean, what I was thinking of when I was listening to that was, I mean, essentially, what's within your control as a developer. I mean, and really, the energy question is sort of, the options are, there isn't a silver bullet at the moment. There isn't. It's not well understood what's the right way to go. You're having to rely on lots of other organisations to give you to deliver that to you. What is within your control is reducing your demand, and so that's where I would be focusing my energy, and I think actually that's reasonably well understood in terms of how we do that. And then those other conversations just have to carry on, and they will carry on for some time, unfortunately.
Perhaps we can take one more question, and then we'll go to the summary.
Yeah. So I've got two very quick questions. But so, are there any reliable studies addressing energy use intensity across the different pathways for the decarbonisation of the grid? So Hamish, my friend from JLL, is asking, is there a kind of helicopter study that says, well, this is the pathway for this, this mix, this. Is there anything that we can look at?
Anybody?
I would say there's not one singular overarching solution. The main sources I use to look at this sort of thing are FES scenarios that the ESO puts out. Those are every year in July, and they look at sort of the supply and demand profiles. It's through listening to over 500 different stakeholders in the industry, and they can bring those scenarios together. So it's a pretty whole systems approach to looking at how we would get to net zero. The CCC balanced pathways give a lot of information as well, and they run their own scenarios, which are really helpful to look at. They're slightly different to FES, and they take slightly different assumptions and approaches. So if you're looking, to get a better understanding about some of the ideas there, I think the CCC is a really good source as well. And then, a lot of the organizations that work for the consumer, really good, Energy Savings Trust, Nesta, these are organizations that are doing their own set of analysis, and they're looking at it from a consumer perspective lens. But if you combine the system operator, the CCC, and the consumer organizations, you might start to get a good picture. But yes, it would be good if they all came together and collaborated on a single version of the truth. But we're not quite there yet.
CCC being the Climate Change Committee.
Yes, sorry. Yes.
Yeah, well, we're struggling to get a definition of net zero, let alone a single source of truth for data. And finally, and this is more of a point than a question. I think it's a mischievous question that they know the answer to. Are there enough skilled contractors to install the technical solutions in homes in the timescale indicated? No, there aren't. And this is a huge problem. I know a bit about this because I tried to install an air source heat pump on the southeast coast of Kent, and there are no technicians in the whole of the southeast of Kent. I had to get a technician from Surrey to come across and give me a quote for an air source heat pump. It is a desperate issue, and the government have completely naffed the situation up by introducing schemes for air source heat pumps that they charge the plumbers to get accredited for, and then taking them away before they could make any money. So it's a massive problem, and it just goes into the myriad of problems that need to be solved.
Perhaps we can move to a summary at this point, because our starting point with this was this decision between the high hydrogen and the high electricity route. And I think we spent the last hour pretty much destroying the premise behind that decision. But I'd still like to ask each of you what you think is the right solution, what the right decision is going to be when that comes up, and what, if you have any insight into which direction you think policy will take. Josh, would you like to take that one first?
Yeah, sure. So, I mean, I guess my answer to that is quite simple, really. I mean, in the context of this webinar, where we're talking about apartments, essentially. I mean, really, I think we're talking about an electric route. I mean, I agree that that we need to explore all options, but I feel that hydrogen is more suited to an industrial or transport based end use, whereas electrification is going to be more suitable for domestic. It also allows us to get going now, and we do need to get going now, and we need to get these solutions, and we can't wait till 2026 to then have another 5 years of trying to work out what to do. So my answer to that is, for a domestic, let's go with electric.
Prashan?
I'd agree with Josh. I mean, the only kind of slight wobbly thing is that if the price of electrolyzers really comes down quickly the way solar PV came down, and countries sort of 30 degrees north, 30 degrees south really take off, there might possibly be scope for really cheap hydrogen quickly, but otherwise I think it's going to be electric resi.
Mm-hmm. And Courtney?
Yeah, I would say I would agree with the other two. There are significant challenges for hydrogen for domestic heating, and hydrogen is such a valuable sort of component of a wider way of living. We do need to decarbonize it, but using it for heating, I don't think is going to be a major solution. It might be in some local industrial areas, but again, you know, back to my earlier point of it's going to need to be a whole systems approach. How are we looking at everything in the round and applying creative solutions in that?
I don't want to. We shouldn't lose sight of district heating. I think it's going to have a role in some of the urban areas.
Yeah, definitely.
Yeah. Okay, Tim, would you like to wrap up? You're on mute, Tim.
Yes, see, God damn it, I did it once. That's the only time. That's £10 to charity pot. I'll make sure I make that donation. So I'd like to thank Atomate and guests for their really interesting debate. It's so tricky. What's really good from my point of view is that people are engaging in this. People are actually understanding that not only is the money it being really expensive really helps. Don't get me wrong. But people are engaging in the carbon debate. People are interested in doing the right thing and getting to net zero. Unfortunately, it's not an easy path, and it's not going to be an easy path to 2050. And actually, it needs to start now. And I think if you go away from today with anything, it would be to reduce. It would be to reduce your own personal consumption and encourage your industries, your buildings to understand the impact of your consumption. The technology people will come up with the tech. We will get there, but not at the rate we're using stuff at the moment. I think it's been a really interesting talk. If there are any more questions, please just email the UKAA. We'll do a little round robin after the webinar. But with 30 seconds to go, I think it's goodbye from me. Goodbye from everybody else. Thank you very much.
Bye.
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 Thank you.